Hi, I'm Rob and welcome to this, our 14th lesson on the topic of trigonometry. And what we're going to take a look at in this lesson is we're going to take a look at graphing trigonometric functions. Another part of this topic which has a lot of real world applications. And this is dealt with in your notes on page 195. So the idea here is if I was to take a function like this, f of x equals sine x. If I start dropping in values for x here, 5 degrees, then 10 degrees, 15 degrees, 20 degrees, and see what answers I get and start plotting those answers on a coordinate diagram, I can draw sine x as a graph. And I can throw measurements of angles in here in either degrees or radians. It's more common for us to be dropping them in radians, because in real world applications we do everything in radians for reasons that will become apparent in the next lesson. But you can throw angles in here in either degrees or radians and then see what answers you get and start plotting those answers on a diagram like that. Now, if I start dropping values into sine x like this and plotting the answers on a graph, if you've got a coordinate diagram like that there, where that's y there and that's x here, if I start plotting, if I put 0 in here, I get an answer of 0. The sign of 0 is 0. And if I start putting in angles and then I'm getting the answers, what I find is the graph goes up like this in an N, goes down like that in a U, and then back to here. So by the time I'm putting in 360 degrees or 2 pi, which remember is a full circle in either degrees or radians in here, I get back to my starting point like that again. Okay, so I get this basic shape here where the graph goes up in an N, down in a U to that point there. Now, if I was to go beyond 360 degrees, if I was to say go to 361, 362, 363, or go beyond 2 pi in radians, what I find is the graph simply repeats again. The graph, I get the very same shape repeated again, then repeated again, and so on. And if I went down below 0, the very same shape would repeat itself down here. So essentially that this graph is described as being periodic. That the values, the answers that come out of the function repeat themselves at regular intervals, which means on the graph, the same basic shape repeats itself at regular intervals. And that's the basic repeating shape of a sine graph here. So once I create that basic shape there, I then start recreating that shape again if I continue going in either direction along the x-axis. So a periodic graph is one where the same basic shape repeats itself at regular intervals. And the sine graph is periodic. Okay? The period then is how long it takes along the x-axis before the graph begins to repeat itself. So after how long on the x-axis do these values start repeating themselves? And for the function sine x, the period is a full circle. It's 2 pi in radians, or it's 360 degrees. So once I go beyond 2 pi or 360 degrees, in terms of the numbers I'm throwing in there, the pattern starts repeating itself. So this pattern repeats itself every 360 degrees or every 2 pi radians. Okay? So the graph is periodic and the period is 2 pi or 360 degrees, depending on what unit of measurement for the angles you're using in the question you're dealing with. All right? What you'll also find with this graph here is that the highest point it gets up as far as is 1, and the lowest point here is -1. So the graph goes up as high as 1, then down as low as -1, then up as high as 1, and down as -1, and just keeps moving between those two values, okay, as you move along the x-axis. So the range of this function is written this way. It's -1, 1. So the smallest number, comma, the biggest number. So this graph goes as low as -1 and as high as +1. So the range of the function sine x is -1 to 1. And what's worth pointing out here as well in this graph is all the important stuff happens in quarters, right? So you can see that if you just take the basic shape here, that you can see there, the maximum point there where we hit the top of the graph, this point here where we hit the center line, this point here where we get to the bottom of the graph, and then we get back here again, that's quarters. So if I divide the period in 4, that's when all the important things happen. So if I divide that by 4, I get pi over 2. So that's pi over 2 there when we get to the highest point on the curve. That's 2 pi over 2, which is pi, is when we hit the center line again. And when we get down here, that's 3 pi over 2. And then 4 pi over 2, 2 pi, and we get back to the center again. So all the important points, turning points where the graph stops going up and starts going down, or vice versa, and points where we hit the center line, the x-axis, they happen in quarters. So if you divide the period by 4, that's when all the important stuff happens. One finding that's worth pointing out about with that graph there is what happens if I was drawing this and I put a negative number there. What does the graph of minus sine x look like? Well, the key idea is that when you put a negative number in front of a function, all you do is you get the mirror image in the x-axis. So if you can imagine the x-axis was a mirror here, what would the reflection look like? Well, the reflection of that N shape there would be a U shape like this. And the reflection of that U shape there would be an N shape like that. So essentially, if you can imagine, just spin that graph around the x-axis. And then that's the basic shape that would repeat itself over and over again then in both directions if I was to keep going. All right, so that's the basic repeating shape of a sine graph. Starts in the middle, goes up in an N first, back to the middle, down in a U, back to the middle, and then that basic shape repeats itself every 2 pi or 360 degrees along the x-axis. If it's a minus sine graph, that gets turned upside down. It starts in the middle, goes down in a U first, back to the middle, goes up in an N, back to the middle, and then repeats that in infinity in both directions. So they're the repeating shapes of a sine graph. So what about the graph f of x equals cosine x? What does that one look like? Well, again, if I start putting values, different angles in here, 0 degrees, 5, 10, 15, or radians, and plotting the answers that come out as a graph, in the case of a cosine graph, it starts up here at the top, starts off at 1 like that. It comes down in half an N shape like that and hits the center line. We then get a U shape like this, and then back up to where we started from. And then again, that point there, that's 360 degrees or 2 pi. That's the basic shape. And again, once I go beyond that point, if I start going beyond 360 or beyond 2 pi, that same basic shape will repeat itself again and again. And if I went down below 0, okay, the same basic shape will repeat itself. So again, that same basic shape repeats itself at regular intervals in both directions, negative and positive. But that's the basic repeating shape of a cosine graph. Starts at the top, goes down as low as to the bottom of that, then back up again, and then repeats from there. And the period and range are the same as they are for a sine function. So again, the period is 360 or 2 pi. That's how, after how long the graph begins repeating itself on the x-axis. And again, the range, the graph goes as high as 1 and down as low as -1. So the period and range of this graph are the very same. All right? And again, if I put a minus sign there in front of the cosine graph, all that happens is we get the mirror image in the x-axis. So the mirror image of that half an N there is half a U like that. Flip this U upside down, we get an N like that. And then the mirror image of that half an N there is half a U. And then again, that basic shape will repeat itself in both directions. Right? So these are the basic repeating of that in all 4 of these graphs, a positive or negative cosine graph, a positive or negative sine graph, the same basic shape repeats itself at regular intervals along the x-axis. It's the same basic shape. That's what it means for these graphs to be periodic. Okay? So what's really important in terms of being able to use these trigonometric functions to solve real-world problems is I need to be familiar with what functions of this form look like. A times sine bx plus c. In other words, if I take a basic sine function or basic cosine function, which we looked at a moment ago, what effect do these 3 numbers, a, b, and c, have on a graph like that? Right? And this is dealt with for you on page 197. And this is kind of really important to try and get your head around. So if you can imagine a function that looks like this, suppose we have f of x equals 5 times sine 3x plus 1. Right? So what would that graph look like? What do these 3 numbers here do to that graph? Well, first of all, notice that we're dealing with a sine graph here, right? And because the in front of the sine is positive, it's a positive sine graph. So I know what the basic shape of that graph is, remember? The basic shape of that graph is it starts in the middle, goes up in an N, goes down in a U, and repeats from there. That basic shape will repeat. That's the basic shape of a positive sine graph. Okay, it's a sine graph where the number in front of the sine is positive. It's a positive sine graph. So that's the basic shape that will repeat itself over and over again, right? Now, if there were no numbers here, remember the x-axis, 0 would be my center line. The graph will go up as high as 1 and down as low as -1. And the graph will repeat itself every 2 pi or 360 degrees. That's what happens to it. That's what a normal sine function does. These numbers here change that. The question is how. So the first thing I would always start off by looking at is the constant here, the number by itself. In this case, that constant, that +1 there, the constant, right? That number there is the center line of your graph. So the constant is the center line. Why? Because remember, a normal sine graph has 0 running through the x-axis. Y equal to 0 runs through the middle. If you add 1 to the function, you move the whole function up 1 unit. So you take that graph and shift it up 1 unit, which means 0 is not in the middle anymore, 1 is. So the key thing here is if I'm drawing a graph like this, okay, the center line like that, whatever the center line is, all right, that's going to be 1 in this case here. So the number by itself, the constant, is the center line of your graph. I would look at that first, right? Secondly then, the coefficient of sine or cosine, the number in front of the sine or cosine, that number there. All right, so I said the number by itself here, that's your center line. All right, that's the line that runs through the middle of your graph. And this number out in front of the word sine or cosine, that number there, okay, that's your amplitude. So that number there tells you how far above and below your center line the graph will go. So this graph has 1 running through the middle. It's going to go up by 5 and down by 5. So it's going to go up by 5 like that. And it's going to go down by 5 like that. So you can see 1, if it goes up by 5, that brings me up as high as 6. And if it goes down by 5, 1 minus 5 goes down as low as -4. So instead of going from 1 to -1 the way a normal sine curve will, this one will go up as high as 6 and down as low as -4. So for this one here, the range is -4, 6. This graph goes from -4 up to 6 and then back down. And remember, that same basic shape will repeat itself over and over again. So these two numbers between them here will tell you what the range is. It's that number plus this guy for the top, and that number minus this guy for the bottom. Okay, that'll tell me this. But the number by itself, the constant, is your center line, and the number in front of the word sine or cosine is your amplitude. It's how far above and below that center line your graph will go. All right? Finally then, to find the period. How long does it take along the x-axis before this graph starts repeating itself? Okay, well obviously that's what this number will tell you. The only number we haven't dealt with, that 3 there, right? And the simplest way to think about what that number there is, that number will tell you what the period is, right? So the period of the graph and that number there are related to one another. And the simple way to think about the relationship is a full circle divided by one of those numbers will give you the other one. So in other words, a full circle divided by 3, by that number there, will give me the period. Or a full circle divided by the period will give me that number there, depending on what direction I'm working from. If I'm going from function to graph, okay, it'll be a full circle divided by that is the period. If I'm going from graph to formula, a full circle divided by the period will give me that number there. So this number here and the period, a full circle divided by one of those numbers will give you the other one. So if I'm working in radians here, a full circle is 2 pi. So 2 pi divided by 3 is 2 pi over 3. That would be the period of this graph. Or if I was working in degrees, remember a full circle is 360 degrees. So 360 divided by 3 would be 120 degrees. So that means the period here would be 120 degrees. And remember, all the important things happen in quarters. So if I divided that by 4, it means that's 30. So there's 30 degrees there. Okay, is when this happens. There's 60 degrees on the x-axis there, where we're in the center line. That's 90 degrees there, and then 120. So once I know what the period is, if I divide that period by 4, that's when all the exciting stuff happens. Okay, top points, bottom points are lines we hit the center line. But they're the 3 things to make sure I can do with a function like this. I know what those 3 numbers are. The constant number by itself is your center line. The number in front of the word sine or cosine is your amplitude, how far above and below the center line your graph goes, up by 5 and down by 5, which will tell you what the range is. And then a full circle divided by that number there. A full circle is either 2 pi or 360, depending on whether you're doing the question degrees or radians, which will be very obvious from the question. You'll be told that. So a full circle divided by that number there will tell you what the period is after how long the graph begins repeating itself. So it's really important that I'm familiar with what those 3 numbers do. So just to complete the set then, if we look at page 199, just the tan function, we don't have to worry so much about the tan function because as you're easy to see now, the tan function doesn't really have real world applications. there aren't any real natural phenomena that can be modeled with a tan function. It's a little bit unusual in shape. But if I was to draw a graph of f of x equals tan x, just what does that one look like? Okay, well, to do tan x, first, if I start filling in values, what you find if I put 0 in there, I get 0, right? And then what will happen there is the graph will curve up like this, right? It'll start going up like that, right? Now, when I get to 90, if I put in tan 90, I get a math error. So I can't, there's no value for at 90 degrees or pi over 2 radians, okay? So at pi over 2 or 90 degrees, there is no point. I'll show you why now in a second, all right? And then once I go, say I go 91 degrees, 92 degrees, what I find is the graph comes up like this, to hit the axis like that in kind of half an N, and then that shape repeats itself. If I go beyond 100, so that's 180 degrees there, that's pi, or 180 degrees. If I go beyond that, I repeat this kind of a half a U shape here, like that, goes up that way. Again, once I get to 270, there's no value possible. That's 3 pi over 2, or 270 degrees. That won't give you an answer either. And then we start repeating that shape, so we get this kind of half an N, then we get half a U, no value possible, and so on. So essentially what the tan graph consists of, it get this basic shape here repeating itself over and over again. So the graph again is periodic. But unlike the previous graphs, this one is referred to, as you can see on page 199, as discontinuous. Because it's not possible to put your pencil on the page here and draw the entire tan graph without lifting your pencil off the page. So if I put my pencil here, I can draw that one, but this one will just keep going up and up and up and up and up infinitely there without ever reaching that dotted line, okay? There's no way I will ever find myself on this part of the graph here. Okay, so these two parts of the graph are not connected to one another anywhere. So if I was trying to draw this with my pencil, I would not be able to draw this bit here and then this bit here without lifting my pencil off the page. That's kind of what discontinuous means. The sine and cosine graphs are continuous. You just get this constant wave, this sinusoidal wave as it's called, that I can just keep my pencil on the page and keep drawing it. But that's not possible here. This graph is discontinuous. Okay, and that's the reason why it doesn't really model any real world situations, right? So you can see here the period of this one is 180. Because it repeats, you can see that in between 90 and 270 here, we get one of these basic shapes, and then we just keep repeating that. Same shape happens again. The same thing would happen here. If I go below 0, I get the other half of that one there, and then at minus 90, there's another line that we never reach as well. So it's that basic shape there, which takes 180 degrees to draw, is the repeating unit there. So the period for this function is pi in radians, or 180 degrees. That's how often, after how long this pattern starts repeating itself. And the range, you'll notice, there is no top value, because that one keeps going up infinitely in that direction, and this one keeps going down infinitely here. That's the Saturday Night Fever graph there, going up and going down, keeps going up here, keeps going down here. So the range, if you're going to write that, you can write as it goes from minus infinity down here to plus infinity up here. But a better way of writing that is it's just all the real numbers. Okay, because it keeps going up forever, going there. There is no maximum point, there is no minimum point, so the range is all real numbers there. Okay, so that's the tan function. And we won't kind of be doing any real world problems involving the tan function because it doesn't really model any real world applications, but that's what the tan graph looks like. Now, the reason why we don't get any value at 90, okay, if you remember that tan of any angle is opposite over adjacent, right? That's what tan is. Okay, it's opposite over adjacent, right? Now, another way of thinking about that, all right? If you said that the tan of any angle can also be written as sine over cosine. Now, the reason that's okay, remember what sine is. Okay, that sine is opposite over hypotenuse, right? That's what the sine above the line is. And below the line, a cosine is adjacent over hypotenuse. So you can see if I divide sine by cosine, I guess opposite over hypotenuse divided by adjacent over hypotenuse. You can see if I multiply top and bottom of that fraction by the hypotenuse like that, because remember, as long as I multiply the top and bottom of a fraction by the same thing, nothing changes. They'll cancel, and so will they, and I just get opposite over adjacent, which is what tan is. Right? Now that formula is given in your formula book, your state exams formula booklet on page 13. Okay, the tan is sine over cosine, okay? So tan is sine over cosine is an important identity that we're going to be meeting in a couple of lessons time anyway. But tan is sine over cosine. Now, if you go back and look at your cosine graph for a moment that we did earlier on, okay, if you remember what the cosine graph looks like, Looks like this. Comes down like that. You get a U shape here and up like that. And look at that point there. Okay, that's 90 degrees, or pi over 2. And at 90 degrees or pi over 2, you can see cosine is equal to 0. So it's on the x-axis here. That point on the x-axis. So the cosine of 90, or is either, or the cosine of pi over 2 in radians is 0. So you can see what that means. At 90 degrees or pi over 2, I'd be dividing by 0 here when I try to work out what tan is, because tan is sine over cosine. So I'd be dividing by 0, and we can't do that in maths. That's why there's no valid value there. All right. So the same thing applies to 270. You can see there's 270 there. Okay, 270 again, cosine is 0. So I'm dealing with 270. When I try to find what the tan of 270 is, I'm dividing by 0 here. I get a math error. So if you were to get your calculator out and try and find out what's tan 90 or tan 270, you'll get the dreaded math error, because tan is the same as sine over cosine. And at 90 degrees or 270, cosine is 0. So you're dividing by 0, and we get a math error. All right? So that's why that those points don't exist on the graph, and the graph ends up being discontinuous. Right? So to finish up this lesson then, if you just look at the questions on page 200. Okay? So you can see here the first question is identify the function shown in the diagram below. So there's 4 things I have to identify here. Okay? I have to identify the basic shape. Is it a sine or a cosine curve? Is it positive or negative? And then those 3 numbers. What the 3 numbers do to this graph. So just if you look at the first one here, question 14.1. All right? First of all, what's the basic shape? Well, look where the graph starts. So the graph starts off here at the number 1. You can see it goes up in an N like that. Goes down in a U like this. And then once we get to here, you can see now the graph starts repeating itself. So you can see we now get that same shape repeated again. Right? So you can see again we go up in an N and we go down in a U. All right? And so on. So that red shape I've got there, that's the basic repeating shape. And the one that starts in the middle goes up in an N first, then down in a U. That's a sine graph. Okay, so it's a positive sine graph. So I know that this graph is the basic repeating shape here is that sine shape. So it's a sine graph to begin with. Now, the 3 numbers. First of all, let me find the center line. Okay, so the center line, remember, so the number by itself is the center line. Look at the graph here. The graph here goes up as high as 4, right, and goes down as low as -2. So halfway between those two would be your center line. So if I just add the numbers together and divide by 2, get the average to find the center line. Okay, so add them, you get 4 and -2. 4 minus 2 over 2. Okay, that ends up being 2 over 2, which is 1. So 1 is the center line. So you can see if I go across from 1, that's the center line of this graph here. Okay, so that's going to be the number by itself. All right, so I know that the function is going to be f of x equals, I know it's some kind of a sine function like that, sine of something x like this, and then the number by itself I now know is +1. Okay, so the number by itself, so the center line of my graph is the number by itself in my function. That's the important idea to get here. All right, now what's the amplitude? Because remember, the number that goes in front of the word sine or cosine here is the amplitude. It's how far above and below the center line of my graph goes. So you can see we're going from 1 up as high as 4, and we're going from 1 down as low as -2. So I'm going up and down by 3. The difference between 1 and 4 is 3, and the difference between 1 and -2 is 3. So the number in front here is a 3. That's the amplitude. I'm going up and down by 3. So this graph has a center line of 1 and goes up and down by 3. That's my amplitude there. And then finally, what's the period? Well, notice here, there's the period. The period here is pi, because on the x-axis, we draw one basic shape when we get to pi there, and then we start repeating ourselves. So once we go beyond pi on the x-axis, we begin repeating ourselves. So a full circle divided by that number there will give me the number that goes in here, in front of the x. Okay? And remember, a full circle here we're in radians, so a full circle is 2 pi. So 2 pi divided by pi is 2. So the number that goes in here is 2. So that function there is 3 sine 2x plus 1. It's a sine graph. Center line is 1. Amplitude is 3. And this number here, dividing a full circle by the period, gives you the number 2. That's the number of times this function, or this basic shape, repeats itself in a full circle. That's what that number there is. So it might be worth just pausing the video there for a second and trying the next 3 just to make sure you can do the same thing. So if I look at the second one here, so again, what's the basic shape? Well, notice we start here down at the bottom. So we start off down here at the bottom, like that. Go all the way up to the top and then come back down here. And you can see once I get to this point now I'm going to start repeating that shape. So you can see now I'm going to start repeating that shape if I go again like this. So what I've got in red there, that's the basic shape here, and starts at the bottom, goes up to the top and then back down again. That's a minus cosine graph. So the 4 basic shapes that we met earlier on, that's a minus cosine graph. So I'm fairly sure this is a negative cosine graph. Okay? That's the basic shape we're doing. It's a minus cosine graph. So the same thing then again, center line, amplitude, and then the period, how often the graph repeats itself in a full circle. Okay, so let's find the center line first of all. It might be obvious here what it is, but just to make sure we know how. So the top point of the graph you can see is 4, and the bottom point is minus 4. So I want to get a number that's halfway between those two, average them. So 4 minus 4 over 2 is 0 over 2, which is 0. So the center line here is 0, so there's no constant. Okay, this graph has not been shifted up or down. 0 is the center line there, so we don't need to write in plus 0. That's the idea, all right? So what's your amplitude? Well, you can see we're going to go up from 0 to 4 and down from 0 to minus 4. Okay, so we're going up and down by 4, so it's going to be 4 times, minus 4 times cosine something x like that. So when it's a minus cosine graph, it means the number in front of the cosine is a negative number. Okay, so it's minus 4, it's not 4 minus cosine, it's minus 4 cosine. Okay, so again, the fact there's a minus sign there means it's that basic shape, the one that starts at the bottom, it's the cosine graph flipped upside down, and the amplitude there is 4, all right? Finally then, what's this number here? Number for the x? Well again, if I find what the period is, and you can see here that the red shape there is one basic drawing of the shape, and the period there is 2 pi. Once we go beyond 2 pi on the x-axis, we start repeating ourselves. Start repeating the shape. So the period there is 2 pi. So if I divide a full circle, 2 pi, by the period, 2 pi, I get 1. So that number there is a 1. And remember, I don't need to include the number 1 there. You can leave that out there. So I can just write there as minus 4 cosine x. Okay, so that function there is minus 4 cosine x. Okay, is a nice easy way to write that one. And then these two here on the next page, page 201. So again, identify the function. So if I look at this first one here, okay, the basic shape, we start up at the top there, come down and you back up at the top. And you can see once I go beyond that point now, that's when I start repeating myself. All right, so that's one basic shape there. And you can see that's the one that starts at the top, goes down and back up again. That's the cosine graph. Okay, so this is some kind of a cosine graph. It's a positive cosine graph. So the 4 basic shapes, positive and negative sine, positive and negative cosine, make sure you recognize those when you see them. Okay, a positive sine graph starts in the middle and goes up. A negative sine graph starts in the middle and goes down. A positive cosine graph starts at the top, and a negative cosine graph starts at the bottom. So because this one starts at the top here, at its highest point, it's a cosine graph. Now, what's my center line? Well, again, the highest point of the graph is 4, and the bottom of the graph here is 0. So if I find a number halfway between those two, I'll add them. 4 plus 0, and then divide by 2 to get the average, and that's 2. So my center line here is 2, so I know this is going to be something cosine x like that, and I know the number by itself now is plus 2. Okay, that's my center line there. Okay, sorry, so the center line runs through the middle here like that. The center line there is 2. Okay, that's the center line of my graph. So the center line of my graph, halfway between the top and bottom is 2, and that's the constant, the number by itself in your formula. Okay, what's the amplitude? Well, you can see here I'm going up from 2 to 4, and I'm going down from 2 to 0. So that means I'm going up and down by 2. So my amplitude here is 2. That's the number that goes out in front of the word sine or cosine. Okay, so it's 2 cosine something x plus 2. And then how often does it repeat itself? Now, if you look at that there, I'm not sure what that is. There. Okay, I think I'd be guessing what that one there is. But notice if I draw another one, there's 2, and then draw one more, 3. There we get to 2 pi. So in this case here, I think that you draw 3 of these shapes in 2 pi. So the period of this graph, okay, is 2 pi over 3. Okay, so I draw 3 basic shapes in a distance of 2 pi along the x-axis. So if I divide that by 3, I get the period for each one of them. That's 2 pi over 3. So now to find this number in here, I divide a full circle by the period. So 2 pi, a full circle, divided by 2 pi over 3. If you do that using your calculator, you get the answer 3. So that number in there is 3. Okay? It's the period of the graph divided into a full circle. So that function there is 2 cosine 3x plus 2. And the last one then, the basic shape here, again, notice where I start. I start here. Okay, in this case, I go down like this. So if I start here, okay, go down, sorry, like this, back to the middle, go up and an end, back to the middle, and then from that point onwards, you can see I now start repeating myself. Okay, so I go down in a U, and then up and in. So you can see that's the basic repeating shape, and then I draw it again and again and so on. So there's my basic shape that I keep repeating there, and yeah, you might recognize that one. That's the negative sine graph. That's minus sine x. This is a negative sine graph, this one. The one that starts in the middle and goes down. So you've got one of each of the 4 basic shapes there in the question we've had a look at here. Again, let's find my center line first. So I know it's going to be a negative sine graph. So you can see that the top value here is 3, and the bottom value here is minus 5. So if I work out what the average of those is, it's 3 minus 5, and then divide that by 2, and you get negative 1, minus 1. Okay, so minus 1, that's my center line there. Okay, that's the center line of this graph here. The graph's going kind of going up and down, oscillating above and below that line there. So my center line is minus 1. So again, I've got cosine something x in here, and the constant is minus 1. So the number by itself there is negative 1 minus 1. That's my center line. What's my amplitude? Well, you can see I'm going up from minus 1 to 3, like that. And I'm going down from minus 1 to minus 5. So that means I'm going up and down by 4. So to go from minus 1 up to 3, you're going up by 4. To go from minus 1 down to minus 5, you're going down by 4. So the amplitude there is 4, right? And remember, it's a negative 4 because it's a minus sine graph. Okay, so it's minus 4 cosine something mx. And notice here, the period of this graph here is 180 degrees. Because once you get to 180 on the x-axis, we start repeating ourselves. So a full circle, in this case 360 degrees, divided by the period, divided by 180, is equal to 2. And that's the number that goes in here, okay, in front of the x. So that graph there is minus 4 cosine 2x minus 1. And sorry, that previous question should be minus 4 sine 2x minus 1. Sorry, I wrote down cosine, but it was a minus sine graph. It was minus 4 sine 2x minus 1. My apologies for that. Okay, so just the last question to finish off the lesson, the one on page 202, we're asked to sketch this function. We don't have to plot it accurately. So I'm not asked to plot the graph here where I get my calculator and do a table and draw these points accurately. I'm just asked to sketch it. It says sketch the graph of this function here, f of x equals 3 sine 2x minus 1. Now, when we get to real world problems in the next lesson, what I would normally be suggesting is when I get something like this, the moment I see a function like that, just do a rough sketch of what it looks like. Okay, you'll see how helpful that becomes when I'm dealing with a real world problem. Okay, so 3 sine 2x minus 1, what does that look like? Well, first of all, remember that look at the function, it's a sine function, and that number there is positive. So what that means is the basic shape we've got here is that one. Remember, that's your basic sine shape. Positive sine graph starts in the middle and goes up. A negative sine graph starts in the middle and goes down in a U and then up in an N. That's the basic shape. A cosine one starts at the top, goes down in a U and back up again. And a negative cosine one starts at the bottom. So just recognize the basic repeating shape. Whichever shape you're dealing with, that shape repeats itself at regular intervals because the graphs are periodic. So that's the basic shape, first of all. That's the sine part. Okay? What about the center line? Remember, the center line is always the constant, the number by itself. Okay, so because the constant here is minus 1, that's my center line. So in the previous questions, whatever the center line of your graph was, became the constant on the end. Okay, in this case here, the constant on the end becomes the center line of your graph. So deal with that first. Whether you're going from graph to function or function to graph, deal with the constant first. The center line of your graph is the constant in your function, or the constant in your function is the center line of your graph. Deal with that first. Secondly, then deal with the amplitude. Okay, so remember the number in front of the word sine or cosine, this number here, that's your amplitude. That's how far above and below the center line of your graph will go. So this graph's going to go up by 3 and down by 3. Okay, so it goes up by 3, minus 1 plus 3 is 2. And if it goes down by 3, minus 3 minus 1 is minus 4. So this graph's going to go from from minus 4 up to 2, and from minus 1 up to 2, down to minus 4, back to minus 1, and then keep repeating that over and over again in both directions. That's the basic shape. And then finally, what's your period? Well, remember, a full circle divided by this number here will give you the period. The same way in the previous questions, a full circle divided by the period gave you that number there. That's the ratio between them. So they're the three things to make sure you're clear on here. So in this case here, a full circle there is this one. You can see that the we're dealing with this one. It says in the domain 0 to 2 pi. So we're working in radians here. So a full circle, 2 pi, divided by that number there, divided by 2 is pi. So the period of this graph here is pi. It repeats every pi units. Now, just one thing to be careful of. So that's what the graph basically looks like here. Because we were asked to graph in the domain 0 to 2 pi, what that means is he wants my x-axis to go all the way up as far as 2 pi. So when it says to graph it in the domain 0 to 2 pi, it means if your x-axis goes from 0 to 2 pi, what does the graph look like? Well, because the period is pi, now if we go to 2 pi, it means I have enough room to draw this same shape a second time. So that's what the graph will look like if I go as far as 2 pi. So that's my sketch. Okay, so again, basic shape. Number by itself is your center line. That's your amplitude. That's how far above and below the center line your graph goes. And this here will tell you how many times you can fit that base shape into a full circle. Or in other words, a full circle divided by that number there will tell you what the period is. And once you know what the period is, you can work out how many of those I can fit into the domain given the question and draw it accordingly. See the second one then, the one below that, it says sketch a graph of this function here. So f of x equals 3 plus 5 times cosine 4x. And where it says, again, in the domain 0 to 2 pi. So same sequence of steps. What does this look like? Well, first of all, what's the basic shape here? It's a cosine function, and the number front is positive. It's a positive cosine function. And the shape of that one, remember, is the one that starts off up here at the top, and it goes down in half an end, and you get your U shape like that, and then back up again. That's the basic shape. There's your cosine shape there. And that's shape that keeps repeating itself in a positive cosine graph. The three numbers. So first of all, what's my center line? Well, there's the constant. It's at the front here. Remember, the constant was at the end here, but it's at the front here because these two numbers here are attached to the word cosine. That's my constant. So my center line here is 3. Okay, that's what runs through the middle of my graph. What's my amplitude? Well, that number there, the number in front of the word cosine is my amplitude. It's how far above and below the center line of my graph will go. It'll go up by 5 and down by 5. So it's going to go up by 5 here. It's going to go down by 5 here. So it goes up by 5. 3 plus 5 is 8. If it goes down by 5, 3 minus 5, it'll go down as low as minus 2. Okay, there's the range. So this graph will go from minus 2 to 8. That's the range for this function. And then finally, what's the period? Well, again, we're working in radians because it says in the domain 0 to 2 pi. So to find the period, I divide a full circle 2 pi by that number there. And 2 pi divided by 4 is pi over 2. So that's the period here, pi over 2. And that's essentially what this graph looks like. Okay, so it goes from 8 down to minus 2, back up to 8, and repeats that every pi over 2 units along the x-axis. But again, I was asked to sketch that as far as 2 pi. So you can see if I draw another one, like that, another one of those basic shapes, that'll bring me up to pi, because pi over 2 plus pi over 2 is pi. Draw it again. You get a little bit rough now. Okay, but that's 3 pi over 2. And if I draw it one more time, like that, there we go up as far as 2 pi. So you can maybe start to see in this case here, that in both cases, that the x-axis goes as far as a full circle, 2 pi, right? And notice how many basic shapes I get to draw here? 2, that number there. In this case, I went as far as 2 pi. How many basic shapes did I get to draw? 4, that number there. So what that number there basically is, it's the number of these basic shapes of the graph I can draw if I let my x-axis run to a full circle, to 2 pi or to 360 degrees, right? So the final two then to finish off the lesson, you can see there on page 203, that it says sketch this graph here. So f of x is equal to minus 7 times sine 3x. And this time we're going from 0 to 360 degrees, so we're in degrees this time, okay? So again, basic shape first of all, well, it's a sine function, right? But the number in front of the sign is negative, okay? So that's a minus sine function, and a minus sine function, remember, looks like this. Starts in the middle, goes down in a U first, then up in an N, and it'll repeat that basic shape over and over again, all right? So that's the basic shape of a negative sine function. Secondly then, what's our center line? Well, the constant is our center line. There is no constant here. There's no number out of subtracted. There is no constant. That means 0 is the constant. 0 is our center line. The x-axis is our center line. When there's no constant, it means that the center line is 0 because the constant is 0. All right? Now our amplitude. You can see the number in front of the word sine or cosine there, that's 7. That's your amplitude. That's how far up and down we go. So we're going to go down by 7 and up by 7. That means we go up as far as 7 here and down as low as -7 here. Going up and down by 7. And then to find the period, after how long does the graph begin repeating itself, I'll divide a full circle by this number here, the number in front of the x. So 360, because we're dealing with degrees this time, divided by 3 is 120, right? So the period there is 120 degrees. And that's the basic idea of this shape here. It goes from 0 down to -7, goes up to +7, back to 0 again, and repeats that every 120 degrees along the x-axis, right? So again, because we're asked to draw this all the way to 360, if I draw another one of those, like that, that'll bring me up to 240, because it repeats every 120 degrees. And if I do it one more time with feeling, coming down like that and up, there we go, 360 degrees. So that's what the graph looks like if I sketch it in the domain 0 to 360. And once again, notice how many of these basic shapes I get to draw. If I let the x go all the way to 360, 3, that number there, number in front of the x. So that's what the number for the x really means. It's how many of these basic shapes can I repeat if I let my x-axis run as far as one full circle. And the way if that helps us is, it means a full circle divided by that number there will give you the period, or a full circle divided by the period will give you that number there. So the last question then, we're asked to graph this one here. F of x equals 12 minus 9 times cosine 2x. And again, we're back in radians here from 0 to 2 pi. So basic shape, first of all, well, it's a cosine function. Okay, it's one of the cosines. And the number in front here is a negative number. Okay, so it's a minus cosine function. And with the basic shape of the minus cosine function, this one here starts at the bottom. Okay, goes up like that, forms an N, and then comes back down. So that's your minus cosine function that way. All right? So that's your basic shape. Work your way through the three numbers. First of all, what's the constant? Well, there's the constant there. It's out at the beginning. The constant can be at the beginning or the end. It's the number that's not attached to the word sine or cosine. Okay, so the center line of this graph here is going to be 12. Okay, so 12 is my center line. What's my amplitude? Well, again, the number for the word sine or cosine, that's the amplitude. So this graph will go up and down by 9. Okay, so it's going to go up by 9, like that. It's going to go down by 9. So if it goes up by 9, 12 plus 9 is 21. Go up as high as 21. And if it goes down by 9, 12 minus 9 is 3. So it's going to go between 3 and 21 is what the range is going to be for this graph. All right? And then finally, what's the period? Well, you can see this number here, the number 2, is the period of the graph. Or sorry, we'll tell you what the period is. If I take a full circle, which is 2 pi, and divide it by 2, divided by that number there, I get pi. That's how often this graph repeats itself along the x-axis, every pi units. So because he wants me to draw this all the way to 2 pi, if I've got room to draw that same shape a second time like that, that'll bring me up to 2 pi. Okay, and that's what the graph looks like if I sketch in the domain 0 to 2 pi. And once again, how many basic shapes did I get to draw? 2, that number there. That's what this one looks like. So just make sure when you're dealing with these trig functions, you know the 4 basic shapes. The basic repeating shape of a sine graph, a minus sine graph, a cosine graph, and a minus cosine graph. And make sure you know what these 3 numbers do. The constant being the center line, the number for the word sine or cosine being your amplitude, how far above and below the center line your graph will go. And this number here telling you how many basic shapes you can fit into a full circle. Okay, so dividing a full circle by that number there will give you the period, or dividing a full circle by the period will give you that number there. And in the next lesson, we'll have a look at how we can apply that to real world problems.